Hello, everyone. My name is Rebecca. I am the city manager for Wagon in London, and it is my pleasure this afternoon to welcome you to the demo day for our data science graduates from batch 475 who have finished a very long 9-week journey with us today. And today we'll be discovering the 5 projects that they have been building over just the last 9 full days. And I think that you'll all be very impressed with what they have all created. I'm going to do a quick little intro about Wagon, and then we'll get right stuck into seeing these amazing projects that they have all been working on. So I'm just going to go into my full screen here. Perfect. So for those of you who don't know about Wagon, as you can probably guess from the name, Le Wagon, I'm sure I butchered that, I always do. We started out in France in 2013. We're a coding bootcamp, and in the last 7 years, we have taught almost 10,000 people how to code and also data science skills as well. So we are present in 40 cities now across the world. So you can go just about everywhere and find a Wagon campus and a tech community around that as well. We have been the best rated bootcamp globally for a number of years now, according to our student reviews, and we're very, very proud of that as well. We put a huge emphasis on product and practical learning at Wagon, and that's what we'll be discovering in just a few moments with the projects that our data science bootcamp students have been building. So we have 2 flagship courses at Wagon. We have a web development bootcamp and also the data science bootcamp, which we launched earlier this year and which our students today have just finished learning on. So the students that have been joining us have very different backgrounds. They have been working in different industries. They have different numbers of years of experience, different career goals after the bootcamp as well. So what really they have in common is this desire to learn actionable tech skills and data science skills in a short period of time. And that, again, that's what we're going to discover in just a few moments' time. So some of them will be planning to join data science teams after the bootcamp. Some of them will hope to work in tech-related roles, such as project management or data product management or tech consulting or something similar. And some may even go on to launch their own tech startups as well. So we're really excited to follow along with you all and give you support to help you take those next steps after graduating from the bootcamp today. Of course, we'll see you all next week for our Careers Week as well. But for now, let's focus on graduating and relaxing and celebrating before we think too much about next week. So over the last 9 weeks, our students have been learning a lot. There have been more than 450 hours of hands-on learning. And during that, they have covered everything from the kind of basics all the way up to the final projects and putting it all together to see what they've been building, which we'll see in just a few moments' time. So without any further ado, let's jump in. Let's discover what you've all built. And we're all really excited to see what that is. So I will hand over to Ben, who is our data science program lead. He will be introducing the projects for us today.
Hi, everyone. Nice to meet you. I'm Ben, the data science lead at Wagon London, and I had the pleasure to follow 20 students during the past 9 weeks. They spent the last 2 weeks building a project in a group of 4. Let's discover those together. Each group will be able to answer a few questions. So on the right-hand side, in the sidebar, you have a questions tab, so don't hesitate to ask questions, and the students will be able to answer a few of those. Without further ado, let's welcome the first group. So our first group is Green Mood Tracker. They wanted to analyze how the public react to the global energy transition. So I'm going to invite Henry and Thomas to join me on stage to tell us a bit more. Take it away, boys.
Hi, everyone.
Hey, guys.
So we're going to share a screen.
Cool. So, hey guys, welcome to our presentation. We're Green Mood Tracker. We're a sentiment detection platform that's focusing on sort of topics around the clean energy transition that we're going through globally at the moment. So why did we decide to do this project? We basically thought that the success of the current global energy transition is heavily reliant on the actions of individuals. It's quite hard to understand exactly how individuals feel about this and how they perceive their role in this current transition. There are lots of questions we need to answer, such as how do people feel about nuclear energy and its threats? What about job security related to sort of transition to energy and moving away from fossil fuels? How are people feeling about energy bills, energy prices? And do these things change with geography and timeframes? These are all important questions we thought needed to be answered. So the question was how we were going to put our new data science skills to use. And we decided the solution was to build a sentiment analysis application using data from Twitter. So Twitter is great for getting lots of data and filtering by topic. It's all public. So this proved really useful. This application would be able to filter by topic, separate by regions and timeframes, and provide you some analysis on that. So how do we actually go about classifying our tweets then? Well, we actually ended up using Google's state-of-the-art new technology, which is the Roberta model. It's a deep learning model that has provided excellent results in terms of classifying language and finding embedded meaning and context and sentences that old models couldn't find. We fine-tuned it with carefully selected data and trained the model. And we actually managed to get 91% accuracy in classifying tweets as positive and negative, which we were pretty happy about. So without further ado, I'm going to pass you on to Thomas, who's going to show you our app and some of the cool features we managed to put into it.
So I'm going to walk you through our website. Our website has two main features. The first one is data visualization, where you have access to our analysis since 2010. And the second one is live analysis. This is where you get to choose your topic, your country, and the year of your choice. So if you want to know how people felt towards, say, fossil fuels in November this year, that's where you would go. I'm going to start with data visualization. The parameter selection works like this. You get to choose the year you want the analysis to be set on, the country, a topic, and a sentiment factor. So we wanted to double check people were actually liking the positive tweets. So we introduced two features. The per tweet feature, it corresponds to what people are saying through their tweets. And the likes per tweet feature analyzes what people are agreeing with based on the likes that each tweet gets. So here we're going to start by, just for an example, at seeing what happened in the USA in 2011 with respect to green energy. So the first map we're getting is a colored map. The scale is ranging from -1 to 1, -1 being negative, which is pictured in a dark red on the map, and 1 being positive, which is pictured as a dark green on the map. And so what we can get from this map is that in 2011, we had pretty diverse information about the USA. So some states were having positive attitude towards green energy, and some states were having a pretty negative attitude towards green energy. It's interesting to look at that, how that evolved over time. So if we move on to 2020, we can see that that map is essentially green. So now in 2020, people have a mainly positive attitude towards green energy. However, we can once again have a look at the likes per tweet and see that it paints a totally different picture. So we can see that regardless of the fact that most tweets being positive, the ones that were liked the most in some states were the ones that were negative, and those are pictured as red on the map. So it's interesting to see that the different information we can get from those graphs. And then the second graph we get from our analysis shows the evolution of the sentiment share over a given year. So if you selected 2020 as we have here, you're going to get the evolution throughout each day of the year. So say on August 31st this year, 74% of the tweets were positive, whilst only 24% were negative. And the final graph is the most straightforward one. It gives you an overlook of the year. It's very fast to understand. So 67% of the tweets in 2020 were positive towards green energy and 31% were negative. And that gives you the whole year outlook. You also have the option to look at the UK, which is classified by region, as is the USA. And it's also a colored map ranging from -1 to 1. And so here we can see, for example, that in terms of nuclear energy, some regions don't tend to agree with respect to the sentiment they're holding. Moving on to live analysis. So the live analysis takes a series of parameters as well. And so you get to select your own time frame. So for example, I'm going to select November to the beginning of December this year. And the list of topics comes from our predefined list of topics. So climate change, energy prices, fossil fuels, green energy, and all that. And what is going to, so our model is live scraping that data and what it returns. So here you can see the 5 first tweets that we've scraped. And the ones that are in green are the ones that have been classified by our model as being positive. And the one in red has been classified as negative by our model. You also get a pie chart once again, which corresponds to the time frame you have selected. And so it gives you the percentage of positive tweets, the percentage of negative tweets. Finally, a word cloud. That basically shows you the most frequent words per tweet at the time frame you have selected. Here we can see that nuclear energy have been used a lot, of course, because we were talking about that, but also clean, solar, moving forward, better. So it's interesting to see what words are coming out the most. So that's it for our application. Thank you for your time. And now let me introduce you to the rest of my team before we answer any questions.
Guys, good demo. Is there any questions for the audience? If you have any questions for Greenwood Tracker, don't hesitate to ask a question in the question tab on your right sidebar. In the meantime, I do have a question for you. Could you expand to other countries or different language, for example?
Yeah, so BERT offers a lot of different sort of like bases for its pre-trained model. So there was a multilingual option that we could work with in the future. But for this task, we'd specifically trained it on English tweets, which meant that the model would only work with English, but in the English tweets. But in the future, we could expand if we found another training set to train in other languages.
Okay, fantastic. Well, thank you very much. Do we have any more questions for Greenwood Tracker? I'll give you a few moments if you want to ask a question. No? Do we have a question in the chat?
In terms of building the web page, we were provided with another software called Demoday, made it a lot easier for us. And that's what allowed us to display all of our data analysis on this web page.
Okay, we also have another question from Laura, which is, what was your sample size? How many tweets?
Overall, we were working with, I think, close to 200,000 tweets that we managed to scrape in our data visualization. That's right, yeah. Around 200,000 tweets.
Fantastic. Well, thank you very much, guys, for the presentation. I'm going to let you go off stage now. I'm going to apply the rotation and go to the next group. Thank you very much for the presentation. That was amazing. Congratulations for the work. Super well done. Thank you very much. Hi, Rebecca. Yeah, our students did a great job there.
They're amazing. I can't join the stage if there's 6 people, so I was like, let me join. Sorry, everyone, if there's a bit of kind of feedback. The students are obviously on campus together, but just in different rooms, so hopefully we can keep that to the minimum as we go. So just as the next group starts to set up, I thought it'd be great to ask some questions to Ben, a bit about more about what the students have been learning during the bootcamp itself. So while the next team is getting ready, maybe Ben, you could tell us a bit about what the students learned week to week during the bootcamp.
Yeah, absolutely. So the students are going to get through all the different modules that you need in data science. So we're going to teach them how to do some data analysis, get the data, clean that data, transform, and then they're going to learn all the basics and more about machine learning, how the algorithms are built behind using the mathematics, and some deep learning, data engineering, etc. So everything is covered throughout the bootcamp. We're telling me that our next group is ready, so I'm going to welcome them. So our second group is London Emotion. Their goal was to map London using people's emotions. Please welcome Aude and Alan on stage.
Hello.
Hi guys, take it away.
Good luck.
Thank you. Okay, let's go.
Let's get the screen set up.
Yay! Okay.
The floor is yours.
Okay, so welcome everybody. We're very excited to have you on board with us to unveil our new website today. So we're a team of 4 people who studied during 9 weeks at Wagon, and we've decided to create this London Emotion project to apply the knowledge required during these 9 intensive weeks. So why are we doing this? So our concept is very simple: one place, one emotion. So when I first arrived in London, I was very overwhelmed by this big city. I didn't know where to live, which place to visit, which place to avoid. So, and I'm sure I'm not the only one who felt that way. So we've decided to create an interactive map which shows the sentiment felt by people in different places spread across London. So, so this is so how we did it. We first gathered the data, then we tried to find the right model. We created the review data set, and then the website is ready to use. So gathering the data, we've created a training data set to test our model. So we combine 3 different data sets composed of daily dialogues, tweets, and sentences. And each of these are linked to one emotion. So joy, anger, fear, neutral, and sadness. So our complete data set is composed of more than 60,000 sentences with one of the 5 unique emotions attached to each. And our baseline model has a 20% accuracy score. Then our model, so we had to create and determine which model we wanted to use to predict our sentiment. So after some researches and some testing, we decided to use a deep learning algorithm. So it's often used to recognize speech and do sentiment analysis. So we thought it would be the perfect tool for us. We created a convolutional neural network which scored a 60% accuracy score, able to predict one of the 5 sentiments on the reviews. And finally, the prediction. So we also had to fetch data for the reviews, and therefore we use Google API to create our data set. So now we have more than 2,000 reviews spread across the 32 boroughs of London. Each borough has 20 places, and each places have between 5 and 20 reviews. So thank you for listening, and now we'll go on to the demo.
Thank you, Aude.
Thank you.
So let's get the website set up. Oh, thank you. There's the app that we built. So this is the visual representation of our data spread. As Aude said, we've got different data from the borough of London. You can see it's all spread around on this map. And now, what does it look like if we put emotion on top of it? With emojis as well. Very fun and interesting. So this is the map we have after we our analysis and put the emoji on top of it. But now it's quite a lot of things going on here. So what we've done as well is to have a simplified map with just the top 3 places for each emotions. So it's easy to see, it's cleaner. So I can see here, these are the places that we have, and we can zoom in, take a look. Seems like a bit angry, just above City Airport. Now the emotions are great, but if you want to see what exactly do they mean, fear not, because we've got some legend on the left-hand side. We can see happy, sad, fear, angry, and neutral. So now going back to the scenario where Aude told us about, when she first came to London, she didn't know what places to avoid, where to go. So for that, we created another map combining 2 emotions together, fear and anger. And why do we choose these 2 emotions? It's because whenever something bad happens in the public space, it usually doesn't happen in a few seconds. It's usually an accumulation of negative energy or some negative emotions when someone gets angry or protest or bar fights, and other people might get with fear. So that's why we think these 2 combinations
is a good indication of some places we should avoid. And if we zoom in a little bit, we can see it's actually a map with the match of the map we had before. It's near about city airport. Maybe if anyone going out tonight, we should avoid that places. And just a note on this map, the heat map represents fear and the bar represent angry. So we can see it's actually matching it quite well. So now we might ask, so how does the neural network works? I know I'll explain it briefly a little bit, but how do we know it's accurate? What does it look like? So let's try it out. We have another page on the app linked to our neural network. It's just a text box where we input something in there, and then the machines will tell us how we feel. So, what's your plan tonight?
I'm going to the restaurant with my friends.
Well, that sounds pretty exciting and joyful. So why don't we tell the machine and see what the machine thinks?
Very excited.
For London, it's great. There are loads of restaurants, and I just miss going to restaurants every now and then. And it's just a good place to hang out, with friends. I'm sure it's really happy emotions, right?
Yeah, I'm very happy to go.
Let's take a look. Oh, great! The machines are actually 99%. That's absolutely accurate. But now, what's the occasions? I mean, anything special happening tonight?
Yeah, I'm going to the restaurant because my friend is leaving tomorrow.
Right. Now I see a bit of sadness in your eyes. Now let's do the machines. If the machines can detect that, let's tell the machines the full story. The goodbye dinners are always tricky. It's always full of mixture of emotions, different feelings. Am I happy? Am I sad? Should I smile? Should I cry? And do I let my friend go? When's the next time I'm going to see them? So let's see what the. Oh wow, great! So we can actually sense you're actually quite upset because of that, but also a bit of joy because it's quite happy to see all your friends. Yeah. Well, I think we're bonding with the machines already, and we just love talking to the machine. But we must put that to the pause. That's basically what our app can do for now. And should we open up to the question?
Yeah.
Excellent.
Thank you very much, and we hope you enjoy it.
Yeah, thank you. Right, so we can see the first question flying in already. It's okay. Right, so I can see the first question flying in already. Someone's asking us, do we actually know what are the places behind the emoji? Do you mind if I take this question?
Yeah.
Okay, great. Okay, so because the way we collect the data is from Google Maps. So if you imagine whenever you click on the place on Google Maps, it will give you the location, exactly where it is, and you can see the review as well. So basically you select this information and find out where they are, and then give it emotion and put it on the map. So if you remember at the beginning of the app, we've got the blue dot on the map. We're just replacing those blue dots with emoji. So we do know exactly what place they are. Thank you. Ben, do we have time for more questions?
Yeah, we have time for one more question. For example, at the moment you map London, but would that work in another city, for example?
Yeah. Oh, okay. Yes, absolutely. Because as long as we have two information, as long as we have the coordinates, and as long as we have some reviews for our algorithm to analyze it, then we will see exactly where they are. So the model is there, the pipeline is there. We can just feed different information into it, different data into it, and then it will generate the map accordingly. So maybe Paris, New York, London, it will just work across the world. And hopefully, maybe in the future, it will work in Mars as well. Okay, thank you very much.
Yeah. Do you want them to answer other questions or not?
Yeah, you can answer another question. Go for it.
So one was, what was your sample size? How many tweaks? So in total, we had 60,000. Yeah, 60,000 for the sample size of our training data. And then another one is, so each location's emotion is representing the top average emotion of those 5 to 20 reviews. And this one, yes, it's like the average of those reviews that we're putting on the map.
Well, thank you very much, guys. Thank you for the presentation. Congratulations. That was really good. Thank you so much. Fantastic. Hey, Rebecca, another great project by our students.
I'm back. So
Yes.
while the other project teams get ready, although they seem super speedy, we planned for a bit of chat in the middle here, but they seem to be ready to rock and roll. So even better for everyone watching at home. I guess a quick question you could answer. I know that there's some people watching who are thinking of joining the bootcamp. Maybe you could talk quickly to some of the skills that our students had before they joined the bootcamp.
Yeah, absolutely. So the only three things I would say before joining us would be having a certain level of mathematics and knowing how to beat a bit in Python, but most importantly, a lot of motivation. So our next group is ready. Thank you, Rebecca, for the question. Next up, we have PlantBase. This one is for the plant lovers. If you want to know more about your plants and how to take care of it, this is the app for you. Please welcome Joshua on stage.
Thank you, Ben. Let me just share my screen here. We can introduce everyone to PlantBase. There we go. Perfect. So, welcome to PlantBase. Thanks everyone for tuning in. I'm going to first introduce the team just briefly. So we've got Anna, myself, Michael, and Roxanne, who spent the last 2 weeks building your personal gardening assistant. So for the keen plant lover who's lost count of their species, for the lockdown gardener like me, who got 2 or 3 plants and immediately forgot what they were, PlantBase is a 2-step solution. So a user can upload an image and get an almost instantaneous prediction of their flower species. Currently, we cover 16 really popular UK garden plants. And then upon that prediction, they'll receive some individualized plant care for that plant. So detailed gardening information for growing, cultivation, pests and diseases. And that's integrated with a quick 5-day weather forecast that just returns some flash warnings if there's any extreme weather coming up. So any frost at the moment, a heat wave potentially, if there's just anything you need to be aware of for your plant safety. And you can see at the bottom here, just a quick top line statistic. So for our top 1 plant prediction, so we return a first plant initially, that's about 60% accuracy. And then return some example images. And if the user thinks maybe that first one isn't right, they can see image 2 and 3. And we're at 86% for our top 3 accuracy, which we're really happy with for just 2 weeks. So just a quick journey. We can just show you how we got there. So from data sourcing, how we developed our baseline, and then kind of what we did to improve that model. So just quick here, how we got our data. It's actually for a plant image classification competition, so it suited us really well. And from that, we took 16 popular UK plants, and you can see there a bit of the numbers. Moving on to our baseline model, so this is where things got started. We were only about 30% accuracy from this. This was quite a basic convolutional neural network. You can see on the right here how we were doing. So on a couple of the species, we're doing quite well. These ones tended to have much higher samples in the data set. But for more than half of them, we were below 10%. A lot of them we weren't predicting at all. So we had 2 main issues with our CNN model to begin with. One, that it was being heavily skewed by the sample size, and the other, that it was really overfitting. It was doing quite well in the training data, but it was struggling to generalize for test data. So these were our 2 big challenges in the first week. So on the overfitting issue, so it wasn't generalizing, we introduced some data augmentation. So each time we ran the model, every time it went through the data, it would transform the images slightly. So it might shift them, it might zoom in a little bit, rotate them. And this just helped the model learn to not just predict the training data, but some variations on that, which is really important because we're taking user uploaded images. We can't guarantee the quality, the angle it's taken from. On the class imbalance, we just use a simple class weighting actually. So this just assigned more value to the classes with less images in the data set. And this just helped the model learn to treat the classes more equally. Onto the exciting final model we used. This is the real beefy deep learning stuff here. So this is our VGG16 model. So this is like a pre-trained architecture. It's been trained on over 14 million images elsewhere. We didn't do that bit. But we used transfer learning. So we took this model, adjusted the kind of output layers to match what we needed. So we needed 16 categories to predict. And that's what we did. And immediately with our data pre-processing, everything we've done, put it into the VGG, and we got a top 1 accuracy of 61%, 86% for the top 3, as you can see. And you can see a much nicer spread of how we were doing on each species. Still some room for improvement, but we're pretty happy with where it ended up in the first 2 weeks. And excitingly, we can do our first live demo. Hopefully everyone can see this. So this is what you'll see when you go onto the PlantBase website. So yeah, welcome to PlantBase, your best friend. And you've got a nice drag and drop here if you want to just drop an image in, or you can browse your files. If you're on mobile, you can take an image on the spot, and that will work. We're just going to do a couple demos here. So this is a really nice clear photo of a plant here. It will immediately turn your uploaded image just so you can make sure you've uploaded the correct one. And as we scroll down, you get a really tiny addiction. Here we think your plant is a geranium. And what we'll show is 2 example images of a geranium just so you can have something to compare to. Thankfully here, this geranium looks very much like this, which is nice. If it didn't, we also return your second and third most likely predictions, just so you've got some scope. You can kind of use a bit of your own eye just to make sure the model's not doing anything funny. But here, yeah, this geranium looks great. We'll click this button just as it loads. Immediately we get our specific plant care advice nicely laid out. You get a little bit of trivia about your plant, some more specific details, cultivation, just for actual growing advice, propagation, if you're interested in growing more of those plants. You've got suggested planting locations if you've just bought the plant, pruning advice, and then for plant health, you've got your pests and disease information. So everything you could really need, all there nicely laid out and responds really quickly. And then on top of that, we've got, at the moment, just a London weather forecast, exclusive London trial of PlantBase. But you get the next 5 days, and you can just see some quick, immediate weather warnings. So we know 2 degrees on Sunday and Monday. So you might just want to make sure your plants are okay. Maybe you want to bring them inside if things are getting frosty. We'll just do one more example, just so you can see. So no need to reload. You can just go back up and browse files again. Here we've got a bit less clear, this picture. Quite a lot going on in the background, and actually it's focused in on the leaf rather than the flower. But again, we predict viola, and actually that looks pretty good to me. So the model's actually quite good at generalizing across. We can just check the other ones just to see. Here I'm pretty happy it's viola. So we can go for there. We can just see how it does. Again, we get our viola specific information. So yeah, really happy with how things turned out. All the information you could need. And I'm going to invite the rest of the team back on now. We can answer some questions, and hopefully, yeah, people can use the app. That would be great.
Congrats, guys. Good job. I do have a question for you. I know you had a lot of images to process. So how did you do with the stockage and storage? And how did you do with in the cloud environment to manage the big size of the volumetry of the images?
Great question. Thanks, Ben. That's obviously your area of expertise, where you've given us some data engineering training we put to use. So there's many possible solutions in cloud computing. What we came up with in the end, we had a 50 gigabyte original data set, narrowed that down to 16 genera of plants, only flower images. Still about a gigabyte. Our VGG model on its own is about 250 megabytes. So our solution was to set up quite a powerful virtual machine on Google Cloud Platform to keep it running, and that machine was able to run through many iterations of our model until we found the best one. And it's also running our app now as a server. So.
Right, thank you. Maybe we have some more questions you want to answer. Don't hesitate to ask a question in the sidebar, guys, in the audience, if you want to know more about the project.
I think we can answer a question from Marie. And so the question is, how would it work if you would have multiple flower per picture? And the second one is, will we share this project, or did we even identify any way to leverage our work? So I will start with the second one. Yes, we are thinking about leveraging the project. The best would be to contact any flower selling platforms who are interested joining our partnership with us. So if anyone's interested, please contact Joshua or Wagon to reach us out, and we are happy to help you out. And the first question is, if you would have a multiple flower picture, it would work very similar. You could have first pictures uploaded and then second picture uploaded. The model would work for both of them. I don't think so there will be any issue about this.
I think there's also the question that Leonardo asked around increasing the number of plants that we could classify. So we started off with the 16 sort of most popular plants in the UK, which is sort of how we went about it. We could definitely increase the number. We just have to increase our data set, which was already huge. So it just kind of goes back to the initial question around sort of managing that huge data set of images and just probably scraping a little bit more. So we could expand it to more. We just need more images to train our models.
There is a question in the chat, which is, when will the app be UK-wide? Available, I think, UK-wide. That's the question.
All right, well, I think the challenge that Josh alluded to earlier was the weather. But we've got a weather API which is trial expanded. We can very easily pull in a search up where you can look up different areas, and I think that'll be probably our next step. It's our easiest win for rolling out countrywide.
Okay, thank you very much, guys. Congratulations on the project. That was fantastic. Good stuff. Thank you very much. Thanks for the presentation. Good work, everyone. So Rebecca, if you want to join stage. Actually, I do have a question for you this time, Rebecca. If I wanted to apply to the Wagon, what would be the admission process?
Yeah, so it's really straightforward. If you're thinking about joining the bootcamp, you send in an application online on our website. Tell us a bit about why you want to join the bootcamp and what your goals are. You'll be invited to have an interview with myself. It's non-technical. It's really just deep diving a bit more into your motivations and what your plans are for the future. And then we do have a technical assessment as well, just to make sure that your level of Python is good enough. As Ben mentioned, 9 weeks is a short period of time to cover off everything that our students have been learning. So you do need to come in with that baseline knowledge before you can start the bootcamp.
Fantastic, thank you. Let's move on to our next project. Our following group is fake news. They were tired of seeing fake news circulating and not being able to know the truth. So they're creating an app to do it automatically. Anne-Sophie, Jonathan, please show us.
Hi, everyone. We're the team Fake News, and we're about to share our slides. Very excited that you're listening to us. So, welcome to our presentation. We're the team Fight Against Fake News. We are 4 people, very international team, all coming from different cities, countries, and with a background in finance, law, and management. All of you probably know the phenomenon of fake news. There are various fake news circulating on our phones as well. There are these really harmless messages or chain messages that you need to pass on, but also more serious ones where people are promising cures against COVID and different tips and tricks. So just to clarify this to all of you, we're building a fake news detector, which is different from a fact checker. A fake news detector detects disinformation, which is a different species or a specific species of misinformation that is deliberately put out there to deceive people and to provoke some kind of negative reaction. It spreads super quickly via social media, much more quicker than in traditional media or than true news. And it's, for example, accelerated by phenomena like super spreader or super sharer, what means, for example, that only 0.1% of Twitter users share 80% of the fake news. A fact checker, in contrast, detects misinformation, which is the unintentional spread of wrong facts on the internet. This is, for example, done via a connection between human, people checking content, and also algorithm installed in your web browser. So how do we tackle this binary classification problem? Because in the end, we wanted to detect either fake news or real news. Our approach was to quantify the bias in a written news article. And for this, we chose a deep learning model. There are mainly 2 types of deep learning models, CNNs and RNNs, and both of them are there to detect complex patterns in textual data. We chose a specific RNN, the long short-term memory architecture, which is used to analyze variable length sequential data. So this slide might confuse you, but it's actually a high-level overview of what happens to your input, to your news article that you put into our app. So the model first takes your news article and kind of magically transforms it into a sequence of numbers, because our model is only able to put numbers into relation to each other, also called vectors. We then train our model, our LSTM model, on our training data, and are able to then predict a certain outcome using our test data. Overall, we're also able to predict an accuracy which shows you or explain you how well our model is working. In the end, you will be able to classify your input article. So I'll pass over to Jonathan, who is now able to demonstrate our app.
Thank you very much, Anne-Sophie. So I will now show you our app. So as Anne-Sophie was saying, most news nowadays is consumed through social media and messenger apps, through relatives, friends, people we know, people we follow. Unfortunately, so does fake news. And we created this app to really be able to detect which article might be true or might be fake. So it's pretty straightforward. In here, in this box, you just copy paste your article, and after pressing the predict button, it will tell you if it is a real or a fake article. So let's put it into practice. We found 2 articles on the internet to put in on a model. So a first one, which is a story about a group of people in the US and Nebraska trying to create a movement to go against the wear of masks because they believe it is against their freedom. Let's put it into work. Just copy paste it very quickly, put it into the app, press predict. Here we have it. It seems to be fake news. So this article seems to be made to actually deceive you. And in fact, it's from the Beacon of Liberty. It is a news outlet that usually provides fake news or tries to share hoax all over the internet. Let's put our second article in, our second example. This one is about a study that has been made to show how streaming outlets, so streaming video, HD quality video, has a higher emission carbon footprint than standard quality videos. Let's put it into our model. Just put it in here, copy paste, predict. We have it. This seems to be a real article. So an article that has been made to inform you. And in fact, it is from the BBC. So you see how 2 articles that are just different topics could be fake or real, and this app is just made to give you an output on it. We also added a little button to tell you again what we use. So we're using a learning algorithm using LSTM, RNN architecture. Our data is from a large trained, so publicly available data sets. And our accuracy rate is at 92%, which means that more than 9 times out of 10, we can accurately say if the article that you input is made to deceive you or actually to inform you. We thank you very much, and we'll now take some questions.
Guys, good job. I do have a question for you. What would be the next step to further improve your model?
Okay, so let me take this question. Yeah, thank you. Actually, there are a couple of next steps that we could do to improve our model. First of all, what is really well known in the data science world is feature engineering. That means adding different features to train the model on to make it more advanced. One of these things is, for example, that we not only look at the text of the data, but also we include title, the length of the title, and so on. Secondly, there are several different options to fine-tune a model using different models itself. For example, we've talked about this LSTM architecture, which we're using. There are also differently refined LSTM models, like the bidirectional LSTM model. So all of these are different steps to take to improve our model further.
Thank you. Thank you for the info. We do have another questions in the question tab, which is how much more complex is it if you were to add a URL instead of copy pasting the text directly, if you were just being able to feed a URL instead of the text?
How much more complex? Oh, good.
Want to go ahead with it? Answer the question, Jonathan, or are you going to?
Go ahead.
I think you'd have to make a web scraper that would essentially go through the URL and scrape out the data. So I don't think it'll be that complex, but it's just there's some issues in given the fact that, like, if you go through sort of articles, they implement images within it and irrelevant stuff. So that would be kind of an issue there. But I think it's achievable.
I see.
Yeah, Joe.
Yeah, we have another question here about our data sets. So which sources that we used. So we managed to find a few data sets on Kaggle, and by combining them, we had up to 65,000 articles labeled as true or false. And on that, we train our model to be able to predict and have a high accuracy at the end.
Also, I'd like to address another question that asks, what would you have to do to check fake news in different languages? So if we explain our model, I talk quickly about the different steps that the data needs to go to be transformed. And what we train our model on is in English vocab. So there are different pre-trained packages of words that are existing out there to include expand the vocab you train your model on. And right now it's trained in English. You would probably have to either create your own embedding set on foreign languages, or maybe use one of the ones that's already out there. So you would have to train your model differently, basically.
Okay, maybe we can take a last question from Laure, which is, what drove you to create this application in the first place?
Actually, I think, like I said in the beginning, it starts with really harmless, like chain messages sent on WhatsApp, but then it continues to like more impactful fake news that not only change the news cycle, but also elections. We've seen some examples of fake news and fake media circulating during the Brazilian elections, but also fake news circulating during the US elections. And some people call fake news the biggest threat to democracy. So we thought, especially in 2020, it's very relevant to use our data science knowledge to create something that maybe helps us or puts us in the right direction of tackling this problem of fake news.
Thank you, guys. Thank you so much for the presentation. That was impressive. Congratulations. That was impressive. Thank you so much. Rebecca, I think we have a bit more time before the next group gets ready. Maybe one more question from you.
Yeah, sure. I just wanted to explain as well to everyone watching at home that the loud noise coming from Julio, that laptop is set up with the room where the rest of the students are sitting watching. So the crazy cheering is from the other data science students.
So you're telling me it's not just Julio just clapping by himself?
I just wanted to explain that one. We never went over that at the start. Okay, so I guess a good question to ask. I know that we've got a mixture of family, friends watching, previous students, some of the teachers that have helped, and also some people who are joining the bootcamp or thinking about joining the bootcamp. So if you could maybe just tell us what you think is the most difficult part of the curriculum that they've been learning, and maybe also the favorite part, the part they seem to have enjoyed the most.
Yeah, absolutely. I would say there's no straight answer for the most difficult part. It really depends on what's your background and what's your skills when you come into the bootcamp. Some parts can be very difficult to apprehend because there's a lot of logical and abstraction in what we teach. But definitely what is preferred by all the students is definitely the last 2 weeks when they finally build everything that they learn together to build the end project. Absolutely. Thank you for the question, Rebecca. We're going to move on to our last project already. So next up, we have 5 stars, and 5 star wanted to take the Airbnb game to the next level. If you want to improve your listing, this is the app for you. Elsa and Miles, please join me on stage.
Hello.
Hey guys, hey Ben, thank you.
Good luck.
Well, this is a lot of pressure at the end of some amazing pitches there and at the end of the course. So we're gonna show you what 5 star is about and do it justice. So it's myself, it's Elsa, Leonie and Ed who've been working on 5 star. And we're quite excited to show you what we've done over the past 2 weeks. It's gonna be about Airbnb hosts, as you say, Ben. It's something that has kind of been thought out of blue and seemed like a bit of a cool idea to investigate. How can you as a host improve the experience for your guests? How can you improve the review scores that you get? And what sort of things can you put in place to do that? Do you need to improve the Wi-Fi? Do you need to provide a bit of breakfast? Do you need to install a sauna unit in your airing cupboard? There are things that can be done, and these are the things that we've found along the way, and we're going to show you in our app today. Why this project? Because I guess we've all got a passion for travel and we love staying in Airbnbs ourselves. In fact, one of our group members is currently staying in an Airbnb and struggling with the Wi-Fi. Is probably going to write a bad review himself, I'm guessing. So we're going to kind of pick apart what that relationship is like with the reviews and the experiences that hosts have. And we know that reviews are a big important thing anyway for customers when they make a purchase decision, but it's equally true for somebody who is looking to book their Airbnb place. In fact, Airbnb actually penalize the listings that have an average review score of below 4.5 out of 5 stars. So to hosts, it's an incredibly important deal that they get their review scores on point and that they know what's generating those scores and how to improve them. In scope for this project, we focused on London only. We looked at existing hosts rather than new ones. And we also focused on start of the year instead of worrying about the impact of the crazy last few months. And after the first couple of days, I realized something, that actually, in fact, review scores are generally quite high. And it's not so much about shifting a 2 out of 5 to a 5 out of 5. It's more about the incremental improvements that a host can make from a 4.4 to a 4.7. And it may not sound a lot, but as we touched on there about the way Airbnb prioritize, it's of huge importance to a host, and we're going to see what contributes to those small gains. So to do this project, we ventured into the world of machine learning and got together a suite of data science tools and methods. We got lost along the way a few times, but that was all the fun in the learning, and we've definitely learned a lot in this project. We started off by looking at clustering. And what that allowed us to do was to group all of the listings into common attributes, whether that be location, price, number of bedrooms, and that helped us analyze those listings a lot easier, but it also, for the host perspective, helped them see what the direct competition was doing, how they were getting their top scores. We looked at NLP because we didn't want to be left out from all the other NLP projects that are happening as well. And so that involved looking at the verbatim comments from guests who'd stayed in listings, the top listings, top reviewed listings, to see what was being said and fed back and see what could be learned from that. And we ended on a model which was pretty cool, which predicted how the review score would change off the back of the attributes that could be tweaked to improve that score. So let's pray that this works, and we're going to hand over to Elsa for a little demo of the product.
Thank you very much, Nice. It is my pleasure to introduce our app, Airbnb 5-Star Predictor. So as a user, we start by telling the app that we are a host in London. And the first part of the app gives us general information on listings that are related to ours. So if we select a borough, a property type, the number of bedroom, and the price per night, the map will display all of the related listings on the Airbnb website. And on the bottom left corner, we can see how many related listings there are, the average price per night for the borough, and whether we're cheap, average, or expensive compared with our direct competitors. Moving on to the core purpose of our app, which is to help hosts understand how they can improve their review score. We give the app our listing ID for a property in Camden in this example. And at the bottom here, we can see our current review score on the left, the average review score of our direct competitors in the middle, and on the right-hand side, we can see how we're doing versus our direct competitors with regards to our review score. Here you can see that we are in desperate need to improve our review score. The next section is based on feedback from customers. This word cloud shows what customers have valued the most when staying in top-performing properties amongst the direct competitors. It can be used in 2 ways. It starts providing us with valuable information in terms of what we could potentially do to improve our review score. So here, for example, we see that a clean property, a comfortable bed, and a friendly host is very important to customers. And it also provides us with information as to what we could put in the description of our property on the Airbnb website to attract more customers. So in our example, it would be wise to mention that our property is locally is well located and that it's close to the Camden Market and to King's Cross Station. And finally, moving on to the last part of our app. This one is based on our machine learning models that predicts review score based on a set of attributes. And here we can see the most important attributes in improving our review score, as well as the impact that moving those attributes would have on our review score. So in our case, if we were to improve the cleaning of our property, if we were to offer breakfast, and to move to a more flexible cancellation policy, we are likely to improve our review score by 0.4 stars, bringing us much closer to the average of our direct competitors. Isn't that brilliant? And that concludes the end of our demo, and now over to Miles for the last few words.
Thanks, Elsa. Well, we just, before we turned over to questions, we just wanted to say we hope you liked our app and got a sense of some of our findings. We've enjoyed not just this last 2 weeks, this project, but we have absolutely loved this course. And I think I can speak on behalf of not just the full team, but of all the teams, that this has been an amazing experience. Thank you to all of the teachers and teaching assistants who've helped with this project and throughout the course. We've absolutely loved it, and we've learned a hell of a lot along the way. So yeah, we'd just like to take your questions and see what you think.
Congratulations, guys. There's a question from Michael in the chat, which is, what would the version 2 of the app look like? Because you've done so much already. So what would you change, improve, etc.?
Great question, Michael. Well, we thought long and hard about this. V2, it could go many different ways, but we thought about thinking of refining the model, which would include looking at the features that we select and think about the permutations of those to improve the accuracy. We definitely think about opening them to different cities. So, Paris, New York, or Hull, my hometown. The options are endless, and also to new hosts, not just existing. And probably the biggest learn would be, we kind of had to focus on continually thinking about the product, the end result, and not just getting lost in like the little decisions of how the model can be made and improved, but thinking about how the user is going to interact with this as an actual app. And that kind of kept us on the straight and narrow, I guess. So we definitely take that into the next version. But great question.
Thank you very much, guys. Fantastic demo. Thank you very much. Congratulations for the presentation. That was brilliant. Thank you very much. That was all of our project. So thank you everyone for listening. That was a 5 data science project that went very fast. Thank you for tuning in. I hope you enjoyed it. On behalf of all the teaching team, I would like to congratulate all the students who worked so hard for the past 9 weeks. They've done a tremendous amount of work, learned so much. So massive congratulations to all of you. Congratulations. And I would like also to thank our teaching team. Sorry, there's some clapping. Our teaching staff that went above and beyond for the past 9 weeks to help our students. They have done a fantastic job as well. So thank you very much to all the teaching staff. Thank you. Over to you, Rebecca, to say a few words. Thank you, everyone.
Thank you, Ben. Yeah, just a few final words from my side. Amazing projects. We are all so proud of what our 20 students have achieved in just 9 short weeks and also in just 9 days on those projects there at the end. So it's quite amazing how much they've achieved. Really, so much hard work goes into making these huge data sets understandable, even for me. So yeah, it's really amazing work that you've all been doing. Miles already started a little bit for me, and so did Ben. But I did just want to take a moment to thank all the teachers who've been working with us and looking after you for the last 9 weeks. It seems like a really long time ago that we all started on the Python refresher back at the end of September. So massive thank you to all the teachers that have been supporting you. It just wouldn't be possible without all of them. Also, a quick shout out to the wider Wagon London team. A lot of stuff goes on in the background, behind the scenes, to make things run as smoothly as they do, especially in times like these. So yeah, a big thanks to all the London staff for all that you do. Finally, the last words are just to congratulate our new graduates, our 20 students today graduating from batch 475. You are joining 435 total students graduating today from Wagon across all of our different cities. So really welcome to the Wagon community. We're so happy to see you here and to see what you're all going to be doing next. So massive congratulations to you all. You definitely deserve a good celebratory drink today and a nice restful weekend. And we're really looking forward to some proper reunion celebrations in the new year when that sort of thing is possible again. So massive congrats. We didn't, it seemed really difficult certain times, but we got there and we're really, really proud and glad that you joined us on this journey. So congrats everyone. Enjoy a celebratory drink and that's it for now. Congrats everyone.
Thank you everyone. Thank you for attending. Bye-bye.